Hello, welcome to my third video for L'Hopital's rule. And what I'll be doing here is just some more examples of how to use L'Hopital's rule. So let's start right away with this problem. The limit as x approaches 0 from the positive side of x times ln of x. So if we just start looking at that by taking limits like we're supposed to, just try plugging things in. You plug in 0 to the positive side into x, you get 0. When we put 0 to the positive side into ln of x, we get, if you remember what the graph of ln of x looks like, it looks like that. So we actually get infinity. So that's 0 times infinity. That's an indeterminate form. And we can use L'Hopital's rule. But to use L'Hopital's rule, we need to first rewrite it as a quotient. So I'll write it as a quotient. The limit as x approaches 0 from the positive side of, let's move the x to the denominator by making it 1 over x, or x to the negative 1 in the denominator. And the numerator we're going to leave as ln of x. So that's mathematically the same. Now if we try plugging things in, you'll notice we get infinity divided by infinity, which is an indeterminate form that we can use L'Hopital's rule on. So we'll use L'Hopital's rule. Take the derivative of the top. First, let me rewrite this limit notation. The derivative of the top is 1 over x. The derivative of the bottom is, think of that as x to the negative 1. So the derivative of that would be negative 1 x to the negative 2, or negative 1 over x squared. All right, well, that's kind of a mess. So let's clean that up by multiplying through by x squared over x squared. And what that will give us is new limit, the limit as x approaches 0 from the positive side. It's all cleaned up. This gives us x on the top, and that gives us negative 1 on the bottom. And you can see that's heading towards, that's just plain equal to negative x. And as x is approaching 0, the opposite of x is also approaching 0. So this is approaching 0. And there we go. We have this problem done. All right, I have another example for us. Let's go ahead and go to that. So example 3b is the limit as x approaches negative infinity of x times e to the negative x. Think about what that's doing. So that would be negative infinity times, as x approaches negative infinity, e to the negative infinity is approaching, that means it's approaching 0. So it's negative infinity times 0. It's again an indeterminate form. And we can rewrite this as a quotient and use L'Hopital's rule. Now, from experience, I've tried this problem going the other direction. I know that we should go ahead and leave the x in the numerator and make the e to the x move the denominator by making it e to the negative x. All right, now again, if we test it, we see that's negative infinity over, and e, that would be e to the positive infinity, so that's also infinity, so that's an indeterminate form. We can use L'Hopital's rule. So we'll take the derivative of the numerator and the derivative of the denominator, and then see what that gives us. The derivative of the numerator is 1. Derivative of the denominator is negative e to the negative x. All right, you clean that up a little bit. You see that's just the limit as x is approaching infinity, that's negative infinity, of negative e to the x. And so as e approaches negative, as x approaches negative infinity, e to the x is approaching 0. So this thing is also approaching 0. Okay, it's like 2 in a row where the answer is 0. It's really not uncommon that this is doing this. It has to do with the power of each function compared to the other, and we'll visit that some more in the next section. All right, let's go to the next problem, example 4. So example 4, we have the limit as x approaches infinity of x raised to the 1 over x. And that's really different. What we need to do with this one is, let's well, actually, we can check the form of it. You see, that's actually equal to infinity raised to the 0, which is one of the indeterminate forms we talked about in the first video about L'Hopital's rule. But what we need to do is let's pick a surrogate variable y, and we're going to we're going to say y is equal to x times 1 over x, raised to the 1 over x. And then, by using logs, we can say ln of y is equal to 1 over x times ln of x. And now if we just take the limit of both sides of this, let's change colors on that. So they take the limit as x approaches infinity, then what we'll be finding is the limit of ln of y. And so let's take the limit of the right-hand side we can't really do anything with. The limit as x approaches infinity of ln of y would be equal to the limit as x approaches infinity of ln of x over x. Okay, I'll change back to the other color here. And so now we can take this limit here, and you see that that's actually L'Hopital's rule in effect, because ln of infinity is infinity, so this is in the form of infinity over infinity. So we can use L'Hopital's rule again, just like we did on the other problems. That's a crazy looking h. Fix that up a little bit. So we can use L'Hopital's rule and take the derivative of the top. So we're going to take the limit as x approaches infinity of 1 over x over 1. And as x approaches infinity, you can see that that is approaching 0. So what that's telling us is that the limit of ln of y is approaching 0 as x is approaching 0. So we need to find out what y is. So we know ln of y is approaching 0. So if we exponentiate both sides, right, e to the power of both sides, we can get y is approaching 1. Okay, so our answer is this thing is equal to 1. All right, well, there we go. That is the last of my videos for L'Hopital's rule. If you have any questions, make sure to seek me out, send me a message, however you want to do it. Thanks so much for listening.